Today I'll solve one pumping power calculation problem. So here is the question. Sulfuric acid is to be pumped at a rate of 3 kg per second through a 50 mm ID pipe over a straight run of 800 meter and is then raised vertically 15 meter. If the pump is electrically driven and has an efficiency of 50%, find the power required by the pump. Density of the acid is 1650 kg per meter cube. Viscosity of the acid is 8.6 millipascal. Now here is the diagram. So transportation of sulfuric acid by the pump. Now data given. So now we are going to calculate pumping power calculation. So let us calculate U. So mass flow rate is given. So that is 3 kg per second. Now pipe diameter is given, internal diameter, that is 50 mm. So that if we convert that 50 mm, so that is 0.05 meter. Now cross sectional area of the pipe, so A is equal to pi by 4 d square. Now pi by 4, 0.05 square, so that will give 1.963 into 10 to the power minus 3 meter square. Now density of the sulfuric acid is given 1650 kg per meter cube. Now mass flow rate M is nothing but rho UA. So now we know rho, we know area, so we can easily calculate what will be the velocity. So now if we plug, so velocity U of the fluid through the pipe, so that will be 0.926 meter per second. Now next is calculate Reynolds number to get idea regarding the nature of the flow. So NR is Reynolds number, du rho by mu. So if we plug du rho and mu, so we will get that Reynolds number is 8314. So as Reynolds number is greater than 4000, so it is a turbulent flow. So if we want to calculate friction factor, so we have to use that this correlation. So that is F is equal to 0.078 NRE to the power 0.25. Now NRE we know, if we plug the NRE, so F will be 0.00803. Now after getting a friction factor 0.00803, so we can calculate frictional losses. So now here total length of the pipe is 800 plus 15, so that is 815 meter. So now frictional losses in the flow system is nothing but 4F L V square by 2GD. Now we know everything, all this value. Now if we plug all this, so we will get HF is nothing but 22.9 meter. Now if I convert in energy unit joule per kg, you have to multiply it with 9.81. So that will give 224 into 6.65 joule per kg. Now we know the Bernoulli's equation, P1 in plus GZ1 plus U1 square by 2 eta WP, then P2 plus GZ2 plus U square by 2 plus HF. Now here alpha 1 alpha 2 is 1. So now, and also P1 is equal to P2, actually open to atmosphere, and velocity tension what is U1 is negligible as it is at rest. Okay, and U2 we know. So now, and Z1 is 0, Z2 is 15. So now if we put, so now Bernoulli's equation will become NWP is equal to GZ2 plus U square by 2 plus HF. Now eta is 0.5, 50%. So HF we already got that, U already we know, Z2 is 15. Now if we plug that, so I will get the WP is equal to 744.46 joule per kg. So this is not, so joule per kg. Now mass flow rate is, that is 3 kg per second. So let's calculate the power required by the pump. The power required by the pump or the power input to the pump is given by, the power required by the pump is PB mass flow rate into WP. If we multiply that, so that will be give that 22233 joule second. So that is joule per second. So that is W33, W means 2.33 kW, kilowatt. That's it.